Namaste students, I am JBN Dr. Aziz Mohammed Khan from Department of Food and Biotechnology, Faculty of Agriculture and Water Science, Jyoti Vidyapith University, Jaipur. Today I am going to discuss about the adsorption. That is the part number 2, adsorption. In the previous video, I discussed about the basic information of the adsorption and absorption. What are the basic principle of the adsorption? What are the types of the absorption, physical and chemical adsorption, and the difference between the physical and chemical adsorption. In this video, I'm going to discuss about some more things in the adsorptions. So in this video, first thing is the adsorption in the liquid and solid. Adsorption in the liquid and solid. So first, discuss about the liquid adsorption. In the liquid adsorption, what is water conducted? A molecule in the interior of the liquid is completely surrounded by the molecule. A complete in the liquid is completely surrounded by another molecules, and so on the average it is attract equally in all directions on a molecule in the surface. However, there is a resultant attraction inwards because the number of molecules per unit volume is greater in bulk of the liquid than the vapor. So in the liquid molecules, the molecules which are inside a beaker, suppose they are inside a beaker, so they are in large number, they are in large quantity, and they are in very contact to each other, and they will attract each other more than they are attract each other in the gaseous forms. So they are very close to each other. Okay. In the liquid, they are very close to each other and they will attract each other very much. And they attract each other as compared to the vapor in the liquid. So this gives rise to surface tension. If they attract each other, then it will give rise to surface tension. Hence, the particles at the surface and particles at the bulk are in different environment. The particles which are in the surface, okay, which are on the surface, and the particles which are at the bulk, are in different environment because there is a surface tension. Okay, and this gives rise to difference in the free energy at the surface and in the bulk. Okay, so in the surface there is a different uh, free energy, and in the bulk there is a different free energy. So the molecules will attract to each other. This will result in the surface tension. This will result in the particle surface energy differences. The energy difference, free energy difference in the bulk, and free energy difference in the surface. So they will be bound to each other easily. Now adsorption in the solid. The solid are also adsorbed. The cleavage of a big crystal of a solid into the smaller unit is done by increasing the surface area. The surface area of solid is much lower than the gaseous form in the liquid phase. Due to the cleavage of the big crystal into the smaller unit, the residual force or vacancies gets generated, and they are generated on the surface of the solid. The occupancy of these vacancies by some other molecules species results into the adsorption. How? The occupancy of these vacancies by some other molecule species will result in the adsorption. So this is the basic mechanism of separation in the uh, li- liquid and the solids. And what are the factors which will affect the adsorption? So the factor which will affect the adsorption include the temperature, pressure, surface area, activation of solid adsorbent. The first one is temperature. Adsorption is exothermic process. Okay, it is a exothermic process, and therefore, in accordance with the Le-Chatelier's principle, the magnitude of the adsorption should increase. The magnitude of the adsorption should increase with decrease in the temperature. Okay, when the temperature is reduced, the temperature will be reduced, the adsorption will be higher. It is in the case of the physical absorption. In the case of the chemical absorption, first increase with rise in the temperature and then starts decreasing. We have already discussed it. And what is the role of the pressure? With increase of the pressure, adsorption increases. Okay, it will increases up to certain extent, till saturation. Okay. When we increase the pressure, the adsorption will increase to a certain extent until the saturation is achieved. Okay, no more, no more adsorption takes place no matter how high the pressure is applied. If we apply a larger pressure, then it will not have any kind of effect on pressure, because at the beyond pressure it will not have any kind of effect on adsorption. So it will depend on the pressure until the saturation point has been achieved. Effect of surface area on adsorption. It's a surface phenomenon, therefore adsorption capacity of adsorbent increases with the increase in surface area. Similarly, the size of the particle of solid adsorbents more is extent of adsorption at its surface interface. So it is surface area, so it will be dependent on the surface area of the adsorption. More area, more adsorption will be found. The activation of the solid adsorbent is also an important factor. The activation of adsorbent surface done. So it is used to provide more vacant sites. If more vacant sites will be present on surface, more adsorption will be found. This can be done by breaking solid crystal in small pieces, breaking lump of solids into powders, or subdividing the adsorbent. So if we divide the crystals, we break the crystals of solids, then it will be more space. We have more space to be provided to the adsorbent. What are types of the adsorbents? So they need to be understood here. First, oxygen containing compounds such as the hydrophilic and polar compounds, and the examples include silica gel and the chelates are also a good adsorbent. Next is the carbon containing compounds or carbon based compounds. They are hydrophobic and they are non-polar. The example is activated carbon and the graphite are the good adsorbents. Polymer based compounds are also adsorbents. They are also type of adsorbents. The polar and non-polar fraction group in a porous polymer matrix are used in the adsorbent, and the examples include the polymer and the resins, which are good examples. What are the types of the adsorbents? The another class is based on the diameter of pore size of the adsorbents. The first one is the microporous adsorbents, mesoporous adsorbents, and the macroporous adsorbents. Three types: microporous, mesoporous, and then macroporous adsorbent. The microporous adsorbent have pore size ranging from the 2 angstrom to 20 angstrom. 2 to 20 angstrom. The range is 2 to 20. In the mesoporous adsorbents, the pore size range is 20 angstrom to 500 angstrom. 20 angstrom to 500. So it is increasing 2 to 20, 20 to 500. And now in the macroporous adsorbent, the pore size is higher than the 500 and so on. Micro has 2 to 20, meso has the 20 to 500 angstrom, and in the macroporous it is above 500 angstrom. The pore size is above 500 angstrom. What are the commercial adsorbent? First is silica gel. Silica gel is used in the drying of the refrigeration. It is used in the organic solvents, transformer oils. It is used in the desiccation in packaging, and it is used in the double glazing. So these are the use of the silica gel as a commercial adsorbent. Activated alumina is also a good chemical adsorbent or chemical commercial adsorbent. It is used in the drying of the gases. It is used in the organic solvent. It is used in the transformer oils. It is used in the removal of the HCl from hydrogen. It is used in the removal of the fluorine in the alkali process. So these adsorbents are used in the procuring steps, liquid separation, solid liquid separation. Okay. So we must understand the use of these chemical and commercial adsorbents. Now, activated carbon. What is the use of the activated carbon? It is used in the removal of the colors from gases. It is used in the recovery of the solvent vapors. It is used in the nitrogen. It is used in the nitrogen from air. Separation of the nitrogen from air. It is used to water purification. It is used for the purification of the different molecules. It is used for the production of the helium also. So these are the use of the activated carbon. Now the use of the polymers and resins as a commercial adsorbent. The polymers and resins are used in the water purification. They are used in the recovery and purification steps of the sterols and amino acids. They are used in the separation of the fatty acids from water and toluene. They are used in the recovery of the proteins from enzyme. Okay, proteins and enzymes. They are used for the recovery of proteins and enzymes. So these are the use of the polymers and the resins. Now the use of the clay. What are the use of the clay? They are used in the treatment of the edible oils. They are used in the removal of the organic pigments. They are used in the refining of the mineral oils. They are used in the removal of the polychlorinated or biphenyls. So these are the use of the clay. And zeolites are also important as a adsorbent. The zeolites include the oxygen. They are used to remove oxygen from the separate oxygen from the air. They are used for the separation of drying. They are used in the separation and drying. They are used in the drying of the gases. They are used in the drying of refrigeration, and they are used in the drying of the organic liquids. They are used in the pollution control. They are used in the recovery of the fructose from syrup. So these are the use. Some more applications of the adsorption is also there, such as the separation and production of the liquid and gas mixture, bulk chemicals, isomers. They are also used in the drying of gases and liquid. They are used in the removal of the impurities from the liquid and gas media and the recovery of the chemicals from the industrial and land gases. They are used in the chromographic analysis. They are used in the heterogeneous catalysis. They are used and effective in the removal of the coloring material. They are used in the removal of the removal in resins. They are used in the exchange of resins. So these are the use of these adsorption, and something which we can explain. I explain it, and in this lecture I explain about the type of adsorbent, the adsorption, the liquid adsorbent, the solids, factors which affect adsorption, types of adsorbents, and the types of adsorbent on the basis of their size, some commercial adsorbents and their use, application of the adsorbents, and we can also add scope of the adsorption. So I hope students will better understand all these things. In in this lecture, some questions can be asked there, such as the explain adsorption, explain type of adsorption, explain the adsorption, the solid and liquids, explain the factors which affect the adsorption, explain the types of adsorbents on the basis of their type and on the basis of their material and on the basis of their size, and what are the commercial adsorbents and their application, and what are the application of the adsorbents. So these all questions can be asked, and I hope the students will better answer all these questions. If you have still have any query, you can ask me. So thank you very much.